Welcome. Welcome. This is the first talk of the day, so I knew there might be some hiccups with stuff, but so far so good. Thanks everybody for coming. This is Hacking with GNURadio. Essentially, I don't know who all knows what GNURadio is here. Fair number of people. Good, good. Who knows what the USRP is? Not so many, but still good amount of people. All right, so the title of this talk: how to have fun with wireless transmissions. I'm David Bryan, security consultant by day, mild-mannered hacker by night. No, CISSP, ham radio enthusiast. I have a ham radio license, hacker, and I volunteer at DEFCON. So I actually am part of the network team that sets up the network for DEFCON so that you can use your wireless laptops and speakers can speak with their laptops and get internet access and all that fun stuff. So without getting hacked, ideally. So a couple of months ago, I think it was March, we went. My wife and I went down to CCCKC, which is Cowtown Computer Congress of Kansas City. Yeah, Cowtown Computer Congress. So this is, I don't know if you can see this, but this is Mitch Altman. He's sort of the creator of NoiseBridge, which is a hackerspace out in San Francisco. I'm really enthused to see these places coming to light because it gives people a place to go and work on projects and work with other people who are maybe more experienced or maybe have actual tools in place to help others. So Mitch stopped in and was selling a bunch of kits. He had his TV Gone kits. I don't know if you've seen them. They're little things about yay big and will turn off TVs from about 300 feet away. So I was playing around with this in the hotels last night. It was quite fun. You turn off the TV and they'd go, oh, the TV's off. Oh, I got to turn that on. And you turn it off. No, the TV's off. I got to turn. No, you don't have to turn it on. You're violating my space. Just shut the TVs off. Anyway, this is Vegas, so that's going to happen. But so I wanted to give props to the hacker spaces out there. I think this is a really great idea, a great concept. If you can participate in these, and even bring together multiple groups, the makers groups, the make groups, the I want to say 2600 groups, the DEFCON groups, those kind of things. If everybody could come together, create a space, you're going to have a lot more resources and a lot more talent. So, all right. How many people know what this is? I got one person here. What is it?
Ultrasonic motion detector.
All right, ultrasonic motion detector. Well, what else does it have on it? Well, it's all right. So, what's that?
Wireless.
Well, it's got infrared. It's called a request to exit sensor. And so oftentimes what will happen is, like let's say the back door to a data center, you'll have one of these RTEs or request to exit sensors that essentially you walk up to it, and if the security company was really nice, they would program it such that it would unlatch either the magnetic lock or the door strike that's on the door. Does everybody know what a door strike is? I got one person. All right, so a door strike is a physical mechanism or an electronic physical mechanism to lock the door. So you on the outside you present your access card to this reader, the door unlocks and it opens the door latch. So some security companies that implement it, thought it was a really great idea to have it so that if you come up to the door, it opens the door and away you go. However, it's going to jump on me again. However, I figured out you can go to the local store and, a drugstore or a large chain, big box, get yourself a nice hot pack, put it on a really long ruler, and sort of slip it under the door. And boom, you're in. So I guess some countermeasures would be mind the gap. Don't have a really big gap, although I haven't done it yet, but there's also hand warmers. I come from northern Minnesota, or from Minnesota, the north, where it's cold, and we use hand warmers in our gloves and our boots so that we don't freeze our butts off and have frostbite. So that might be another one. They're really flat.
Compressed air works too. It's upside down.
Oh, compressed air. Well, except it's looking for heat, though. Not
Or the absence of heat.
really? Are you sure?
It's looking for change.
Oh, it's looking for a change in heat. All right. Well, so I'll have to test that. So compressed air would be like the freon or the propellant that would send it a change. But it's looking for a change in temperature, but it's also looking for motion. So the big deal that I have heard, as sort of a story for a long time was, oh, well, you take a Mylar balloon, you fill it with helium, you shove it under, fill it with helium, and it floats up and boom, it opens the door. Well, that doesn't really work because I took a balloon, went out to the local big box store, got a rubber hose, got a bunch of balloons, got some tin foil, got all sorts of materials, and started hacking away at, all right, can I get into this door with this? Nope. Can I get into the door with this? Nope. Oh, hey, look, can I get into the door with this? Yes, the hot pack. So, and it kind of came to me as I was, exiting the door, this is more authorized pen test, I guess, rather than a black boxed pen test. But essentially, you walk up to it, and if your hand's moving, I had long sleeves on. Your hand's moving. It sees that little bit of heat and that little bit of movement. Boom, the door opens. So, anyway, any questions on that one? I see one way back there. I can't hear you. Yeah, thin foil heating elements. All right, so the other thing I thought about was, what is it, now I'm totally blanking on it. But essentially, where you've got one side that's hot, one side that's cold. Peltier, yeah. Except you might burn it out, because you have to have a heat sink on the other side in order to get it to turn on. But, maybe if you're trying to get in, you just run it 3 seconds at a time. It's not going to burn it out. All right. Crash bar, push to exit. So that, if you actually are going to exit, you push a button instead of doing that. All right, now on to the main topic. I do have a 2-hour slot here, so if people want me to talk faster, that's fine. I'll probably go for about an hour, hour and a half. The original talk is slated for more than an hour. But all right, what is GNURadio? So, talk about what is GNURadio, what you need, some of the requirements, some of the cost behind the hardware. So GNURadio is software for the most part. It's an FPGA that sits on a board that has a bunch of, 8 digital or 4 digital analog, 4 analog to digital converters. Essentially it runs Python. Python is good because it's compiled bytecode, at least before it runs. And it uses software. So, does anyone have any questions on Python? No? All right. Python's good. Makes you code properly so that you can read it when you're done. Anyway. All right, so this is the USRP version 1. This is what I have sitting up front here. It's a lower bandwidth wireless radio tool, but it works. Some of the daughter boards, this is actually a picture of the main board. As you can see, it's got a transmit and receive side and an A and a B side. Essentially, the daughter boards plug in on A or B and then on transmit or receive. So, and here's a look at the top side of some of the boards. So, let's see, we've got the Flex 2400, which is 2.4 gigahertz wireless. And we've got, what's that one down there? It's the 800 to 2400 receive board, and then a basic RX, basic to receive board. I just have the 2.4 gigahertz and 900 megahertz, or 800 to 1 gig board, because it'll do transmission. All right, so how can I use it? Well, you get the hardware, USRP. I would highly recommend installing Ubuntu. I'm not going to go off onto OS wars. However, there are packages that work for Ubuntu, so you can install Ubuntu, install the the dependencies and get the stuff up and running in about an hour. I tried for several days to get it to work on, what was it, Fedora and CentOS. It was just dependency hell. I mean, several days of working at it an hour at a time and doing other work and coming back and working at it. Finally, I gave up and said, all right, I'm just going to install Ubuntu, and essentially, like I said, there's a package tree in there for the dependencies. It just goes out, grabs everything, you download the stuff or pull it out of Subversion. Does everybody know what Subversion is here? So Subversion is basically a source tracking tool. Allows you to check code in, check code out, and most Subversion repositories have an anonymous feed, so you can go to the Subversion repository, pull out the latest and greatest code, which is more than likely going to work properly, and then compile it from there. The biggest part is getting all the dependencies in so you can compile the GNURadio software. All right. It does require USB 2.0, which is a big bummer because, and I think it's high speed versus fast or something? Full speed versus, yeah. So I found out the hard way on my MacBook at home that it doesn't work on there because it doesn't have the full speed USB 2.0. But that was after hours and hours of getting all the dependencies and compiling and going, oh crap. Anyway, the new version is much faster and requires much more processing power, and so they've gone to using a gigabit Ethernet interface. So you essentially are using a raw Ethernet frame component between the USRP and your computer to talk to it. Makes it so you can do a lot more bandwidth because the USB bus is limited to the amount of bandwidth that you have between the two systems. So, all right. So some costs. The USRP 1 is about $700 right now. The USRP 2 is about $1,400. It's pretty expensive in my opinion. I mean, not for the mild-mannered hacker to go out and purchase. The daughter boards that run anywhere from $75 up to $400. Screws in the case. I think the case is probably a good thing, but unless you have a lab or a bench you're going to be testing it on. So, and the biggest thing about this is it's not specifically FCC part licensed. Does anybody know what that means? I got one person. I got two people. Three, maybe. Does anybody want to say? So, FCC part licensed is basically a class license where, for example, my ham radio can transmit on certain frequencies. If I modify the radio to transmit on other frequencies, it's now not FCC part licensed, which means that it's an illegal radio, essentially, by FCC standards. The other thing is I can now transmit on just about any frequency that I want since it's a research tool, right? I mean, that's what it's been used for. And because of that, you can own your neighborhood network, SCADA. Priceless, right? Anyway, I guess the concept is that because it's not part licensed or part typed, you can actually have it transmit on frequencies that you wouldn't normally be able to, which we'll sort of talk about in a little bit here. Does anybody have any questions on the cost or the hardware? No? All right. So what can we do with it? What's that?
What is the meaning of SCADA?
Oh, SCADA. Oh boy. You're going to have to, it's an acronym that is, what is it? It is, it's basically, control networks. It's for, yeah, thank you. Control and data acquisition. Of course, someone's going to ask me that. It's a very long acronym. But essentially, a SCADA network would be, like at your power plant or your water plant or some sort of utility that has devices out there monitoring the flow of water or the flow of electricity, and either will turn things on or off based on that, or make decisions based on what they see from those devices out in the field. All right. So some wireless attacks that you can perform or that people have performed with GNURadio. RFID payment cards, the MyFair cards, they've absolutely been cloned, and they can replay those cards back to the subway attacks. GSM attacks, Bluetooth, using multiple devices to do some frequency hopping following, essentially, and then MAS, multiple access system. All right, so yeah, RFID, essentially the RFID tag reading, the Boston subway hacks, where they used a USRP as well. MyFair card attacks, that's been a long published one. I think it's about 2 or 3 years now, 2 or 3 years old, and they use a USRP essentially, or were using a USRP originally to do a lot of the attacks. And then there's the possibility of doing long-range tag reading with something like this, because you can, put a linear amp in front of it and jack up the signal that you're using to read that tag. I think there was a talk, or there's a contest this week to do a long-range read on a RFID tag, if I remember correctly. So, all right, there's GSM attacks, A5 cracking. A5 is the encryption algorithm, or the older encryption algorithm that has been used in GSM. A lot of companies have upgraded to, I think, the next standard, which isn't as easy to break, but that was the old standard. The other thing you can do is you can create your own microcell. So essentially, if you wanted to route all cell phone traffic through you, set it up. Or a cell-free zone, which is my favorite. So, yeah. All right, so the other components or other attacks are Bluetooth. Does everybody know how Bluetooth works? It's a frequency hopping, which means that, so like your traditional 802.11 wireless is direct sequence spread spectrum, which means that it follows a line, and you can fairly easily follow that signal and go back and actually do a network dump or some sort of a wireless dump of that signal as it's going in direct sequence. Whereas the frequency hopping will take that bandwidth or that set of channels, and it'll hop around the channels really fast. There's been some research with the USRPs where they can essentially dump all of the frequencies all at the same time, using 8 USRPs all in parallel, and then decoding the data. So essentially they can track, like a Bluetooth headset, for example, track where it's at, dump all the data, and then crack it offline very quickly. Just with the way that it sets up the connectivity between the two. Yeah, so the USRP version 1 lacks the bandwidth really to do that. But you could put up a denial of service attack, just do some sort of a wide band broadcast on the 2.4 gigahertz, and everybody's Bluetooth goes away. All right, so this is my custom research that I've done. MAS system, called multiple access system. It's what SCADA companies will use to set up a network to transmit data in between points, or to move data in between points from, a pump, for example. What I found is in doing the research, basically we were engaged with one of our utility clients to figure out, hey, what can we do with this network? Is it vulnerable to attack? I went and found out in this 1992 issue of IEEE, hey, look, there's this thing about this 900 megahertz spectrum, and talking about, oh yeah, it uses 928 and 952. Oh, interesting. All right. And I mean, it's a simple 1992 repeater style technology. Does everybody know what a repeater is here? Few people know. All right. So repeaters generally have an input frequency and an output frequency. The input frequency would be coming from, in this case, the head end. And then the output frequency is the blue lines here. going to all the remote sites. Anytime traffic happens on this, like for example, they want to check the status of pump B over here. They would send to the repeater. The repeater would then rebroadcast that signal. The head end would stop transmitting. All the endpoints would receive that message, and the endpoint that actually was supposed to respond would then pick up and transmit back to the repeater, and the repeater would transmit it back to the head end. Does this make sense? Understandable? All right. Yeah, the reply message is essentially going back to the repeater, and the head end then receiving it. All right. So what do you think are some attack methods in this particular instance? Attack the repeater? To be a repeater, that would be a good one. But that requires a lot of power. I mean, I think this is a 50-watt transmitter, which is pretty big. I mean, you can go 25, 30 miles with 50 watts. Any other attacks? Intercept it. That's a good one. That's very easy to do. Act as a head end. Absolutely. So essentially, evil hacksaw comes along, and this is what I did. I pretended to be a head end or a remote agent in the field. Okay. Decode, decrypt the traffic. That's one potential. Inject, DOS. I went for the easy one. DOS. I mean, I can DOS this network repeater. I know that their network isn't going to function anymore, and that's a pretty big component in my mind as far as security is the availability of that data. In this particular instance, confidentiality, not so much. Integrity, absolutely. You want to make sure that you're getting accurate readings from your remote sites, and you also want to make sure that when you send a command to the remote site, that the integrity is maintained throughout your network. Confidentiality, not a big deal. I mean, who cares if they know that the tank is at 320 feet, of water and whatnot, All right, so evil hacksaw. First attempt was with a little tiny antenna. And I was like, well, let's see if we can get this to work. I got right underneath the repeater, keyed up, and it didn't work. I was like, damn, all right. So second attempt was with a little bit bigger antenna. This is my ham radio antenna for my mobile or my car unit. I think it's got a 8 decibel gain on it, I think, at 900 megahertz. And it didn't work. So I was like, all right, there's got to be a better way. I gotta find a way to do this, because this is insane. The third time is the charm. However, I used an antenna that was much bigger. And in fact, here it is. I'm sitting outside the curb with this big antenna and a tripod, and all I'm doing is keying up on that input frequency. I'm not actually sending messages, spoofing status messages. Nothing. Well, there we go. Nothing. I'm just keying up on the frequency, and boop, com fail, com fail, com fail, com fail. So, essentially, I created a denial of service. They now can no longer manage these devices. Great. Oh, that's not so good. All right. However, I'm talking with the guy on the phone saying, hey, all right, can you get to your stuff? And he says, well, nope, it's all down. Okay, can you turn a pump on? Nope, can't do that. All right. I said, well, that's not a very good thing in this particular case. And he said, well, yeah, but we all, there's PLCs in the program logic controllers that are in all these pump houses that, at 3 o'clock in the morning, they'll turn on, they'll pump up water to a certain level, and they'll turn off. And I said, oh, that's great. Except if they're in admin override mode. And I went, oh. So if they're in admin override mode, they don't turn on, they don't turn off. And someone has to go into the 50 or so pump houses and turn the pumps on at 3 o'clock in the morning. That's not a very good or efficient system. Essentially, evil hackers own the system. If I had more time, yeah, I don't know. Do you guys know how consulting sometimes works? Consulting engagements. Generally, you'll try and say, all right, I think it's going to take this amount of time, and you try to go towards an intended target, and if you go beyond that, you're kind of out of luck. You don't have a lot more time to put into it. In this case, I spent a lot of time getting GNURadio working, getting all the components ready, and at the end of the day, I couldn't actually sit down and start to decrypt or decode the packets. However, it's not encrypted, so it's not very hard to go back and actually do a lot of those attacks, and then start spoofing the traffic from the head end, putting things in maintenance mode, etc., etc. So, yeah, some of the issues, it's wide open. There's no authentication, period. No integrity, period. It's got a single point of failure, essentially from the fact that the repeater is doing all the work in that network. If it was a mesh network or some sort of fail-safe network, you'd at least have a backup if someone DOSed the repeater. In my opinion, this is a very poor design. There should be much stronger controls in place. I got a hand over here. All right, so what are the consequences of a pump not turning on at 3 in the morning? You don't have water, or you run out of water halfway through. So it's a denial of service of the network could create a denial of service of the utilities, which could create an outage for people, and depending on if it were a multi-threat attack, it might cause some unrest to the community. Another question? All right, I didn't hear the question. What?
How close were you to the head end, and how would you go about trying to find them?
Oh boy, so that's another question. All right, the question is, how close was I to the head end, and how would you go about finding these head ends? Well, so I was very close to the head end, within about a block. How would I go about finding them? Well, the FCC has this wonderful database. Has anyone ever heard of ULS, Universal Licensing System? Yeah, so essentially, you can go to ULS. I think you can enter in GPS coordinates, lat long, and it'll show you what the transmitters are around you. I mean, as any typical radio engineer would need to know this stuff so that they could figure out why their signal's being impeded on, right? Or you could just go look for the name of the company, because generally if in this particular case, they licensed the spectrum for 10 years, and it's going to be under their name, and then in that ULS thing, they're going to have lat-long coordinates. That's something I didn't include in the talk here, but I did that as well. I was like, oh, look, this is all public? Yee. I don't know that I want everybody to be able to find these transmitters and, knock them down, essentially. So... All right, so some MAS or multiple access system radio fixes, use encryption on top of it, or use some sort of hashing mechanism that you now know that there's some sort of integrity check between the endpoints. Another thought is maybe use some sort of 802 type 11 or 802.11 type network where you can put it in a mesh networking configuration so that if one node in the network goes down, it doesn't take all the network out. Self-healing networks. I don't know. Maybe not self-healing, but at least have some redundancy in the path. A lot of times, if you've got a tower, you generally could have 2 or 3 points to hit between different towers. Excuse me. All right. Also use out-of-band management for some of these so that you're not managing this stuff in-band. In-band would be inside the network. All right, so I think now we're going to do a little demo. And hopefully it works and doesn't crash. I don't think it will, but... Does anybody have any questions about stuff so far? No? All right.
So
So the data that I did collect, well, really I was looking at the spectrum. I didn't I didn't actually get a protocol block decoder and dump the data to disk yet. I just didn't have time, you know. It would have taken, because first thing I would have to figure out is, you know, how big the spectrum it's using for the transmission of the data. You know, how do I chunk it up and write it out? I didn't. It's that 928, 952 frequency. Yeah, and I don't think it was very wide. What's that? Oh, I don't know. Yeah, I didn't go that far into it. All right. Nobody's got a laser beam pointed at my computer, right? Damn. Yeah, I think so. All right. So this is essentially the attack. I use this tool, which is a push-to-talk tool. Let's see. So we'll see if the audio actually comes through. I don't think it will, but. Woo. That's it. So I've now got a carrier frequency that I brought up via the USRP that's, you know, not part licensed essentially to operate on the frequency. So that's it. That was it. It's so simple to break the system because there's no coded tone squelch or PL tone or digital coded squelch. None of that stuff. It's just input frequency, transmit out. Does everybody understand that? All right. So that's essentially the tool that I use to pwn the network. It's so simple that it's kind of like, well, I mean, it worked though. Most networks shouldn't be affected by that. Yes. This is 1996, 98 implementation of SCADA, wireless SCADA. So, yeah, a lot of the ones that are, well, I don't want to say everything's easy or more secure. If it's on an Ethernet run, it has a potential to be more secure. However, a lot of people will put them on public networks, you know, or in bad places or poor places. Or they'll put them next to their users who might get infected, who then, you know, in turn could be scanning these systems and they crash. Oh. So you can't buy an off-the-shelf radio to transmit on these frequencies because it's part licensed. So I would have to go buy an MAS radio in order to transmit on those frequencies, because those frequencies are licensed specifically for each product, essentially. So because this product is not FCC part licensed, I can transmit on any frequency. And so the FCC will only license radios for certain spectrums and certain frequencies.
This is the dumb part of it. Why couldn't you have bought a part licensed radio and changed capture frequency?
Generally, you probably could. It depends on the radio, though. It probably wouldn't do it in that spectrum. Most of the radios are actually locked in software somewhere as to what frequencies you can actually transmit on. Some of the reprogrammable ones, you might be able to do it, but in this case, I don't think you would be able to, since it's a closed spectrum or licensed spectrum. Saw another hand over here. No. All right, now let's go on to the next sort of thing here.
Did that attack, what OS were you using, what software?
Ubuntu?
Ubuntu? Oh,
Yeah.
I just saw it was different laptops. So.
No, it's this laptop.
Oh.
Yeah, it is actually this laptop. So, all right. So now the next thing I have is sort of if you had a bug in your house, how would you find it, right? And we'll kind of show you here. All right, so does everybody see that waterfall? It's called a waterfall. Essentially, it's showing an oscilloscope for all intents and purposes. Has anyone ever used Y-Spy? Little Y-Spy tool? I see a couple people. So Y-Spy is really neat spectrum analyzer. It used to be $99, now it's $350 or something, I think, for the Pro. But it's kind of a cool tool, similar to this, only this we can operate on multiple frequencies. All right, so I brought a little camera along with me. A little wireless camera, yay big. We'll take and we'll plug it in. Does anybody notice a difference? So I can actually. I'll show you that here in a second. Sort of. Yeah, someone hasn't written the H-Sync V-Sync for it, but I'll show you. Or they haven't checked it into CVS or a Subversion, which is kind of a bummer. But so now you could take like a directional antenna. I've got a couple of handmade directional antennas up here. If you want to see them, that's great. I've got a biquad antenna and a dipole. They're actually tuned for the 2.4 gigahertz frequency, but they'll pick up other stuff. Obviously, not so great, but at least it'll be somewhat directional. What's that? No. The camera's not MPEG. It's just transmitting raw video and raw audio right now. But as you can see, it's a wideband application. It's using a boatload of bandwidth in the frequency.
Put it up like 850 megahertz, and then we'll walk up there with a cell phone and send a text message.
Oh yeah. That actually, I can actually.
Try that later.
All right, we can do that. 850 megahertz. I'm willing to play with this if people want to look at spectrums while we're here. Absolutely. All right, so we could also look at, let's see, the 2.4 gigahertz spectrum. Here, I'll show you that in a sec. So that's this antenna right here. I don't see, where's Louise, where are the access points in here? Oh, there's one over there. All right, so it should pop up with some, there's one over there. All right. And of course it's not working. I was up in the NOC and I was seeing a good solid line of things, essentially where the center frequency is of the direct sequence spread spectrum. See if I boost the gain on this. There we go. So you can kind of see, where's my pointer? You can kind of see there's one line developing right here. So that means that we got an AP probably on channel 8. I'm assuming, since I just took the 2.4 gigahertz frequency and centered it on there. What'll happen is you'll see, a line here, a line here, a line here, and a line here for the wireless transmissions, essentially. That you can then say, okay, that's DSS, direct sequence spread spectrum. All right. Oh, I think this is, yeah, that's fine. All right, so question about TV, right? Can I view the signal coming off of this camera? So, like I said, there's no horizontal and vertical sync checked into the archive, but it's the camera. It's just out of sync. So if I wave my hand in front of it, you can kind of see. Yeah, it's like scrambled porn. Wow, chicka wow wow. So, but that's it.
What daughter board are you using for the TV?
So the TV receiver question was, what daughter board am I using for the TV? This is just the 900 megahertz one. So essentially, if you've got cameras that are in 900 megahertz or 2.4 gigahertz, you should be able to pick it up with this. Now, if someone checks in the code block to be able to do the horizontal and vertical sync, this would show up nice and pretty. I worked on this Sunday for a couple hours going, well, why isn't this syncing? Why can I not see the sync? Oh, because the block isn't there. You know, I actually put it into the Python code and ran the script, and it said, hey, this block hasn't been checked into CVS yet. I'm like, anyway. So, but at least it gives you an idea of what something would look like when it's transmitting, specifically a 900 megahertz video camera, and then the fact that you could pick up on it. I mean, absolutely pick up on it. You know. So, all right. The other thing you could do is you could do, you know, audio pickups. There's the boards, the lower frequency boards, which will receive quite a wide amount of images and audio and stuff like that, and do full HD TV decoding, things like that. Oh, apparently it's been pulled out of 3.2. Okay. So it's been taken out, which is a bummer. Hopefully, maybe it'll come back working. All right, so back to the Prezo. Oh, come on. Yeah. Can I do Shift F5? It's not going to do it from that slide. Oh, there we go. Good. All right. So essentially we did, you know, how can you find a bug, right? How to know your friends, right? You know, transmitting on frequencies that maybe they're using. How to make lots of money, no clue there, but it's fun. It's fun to do this stuff. So one thing I want to say is, how can I contribute? Definitely, you know, go out and pursue hackerspace, makerspace, some of the DEFCON groups. I don't know if people know about DEFCON groups. My wife and I run the DC 612 group in Minneapolis. Essentially, it's a place for people to get together who are like-minded, who would come to this type of conference, talk about things, and, you know, do things. I think there's talk about doing things like the darknet. I don't know, do people know what darknet is here? I got one person, two people. All right, so darknet is a place where people can sort of join in on the network and hack away at each other without having to worry about, you know, either being seen or being sort of taken down is what I would call it. If your ISP doesn't like the traffic they see, they could take you down. With a dark net, it's all in an IPsec tunnel between friends. So, however, you have to make sure that that box is an ownable box, because it may get owned very quickly. The other thing is post. So if you make code, post the code back to the archive. You know, I think that's the biggest thing, is the contributors from the community that make this software good. And I want to see more people playing with it, so that it'll drive some of the hardware costs down. I think the hardware for the USRP is very expensive in my opinion. I think it should be a sub $500 product, and then we might see more people playing with it and doing cool things. And then of course have fun with it, because if you don't have fun with it, what's the point? So, all right, so that is my talk. I'm more than willing to stand up here and play with the transmission, you know, 850 megahertz, and see what happens in that certain spectrum, or do whatever people want to do. So, thank you.